hopefully you're having fun with integration by parts. We're going to just tweak it up a little bit, make it even more fun. At the end of this lesson, you'll be able to evaluate an integral using integration by parts, not once, but maybe twice or maybe 3 times. So let's get going. Alrighty, if we look at this example, evaluate the integral of x squared e to the 2x dx. Alright, if we're taking the integral of this, use substitution will not work. I would notice that in order to take the derivative, I would need to use the product rule. So once again, this makes it an excellent candidate for integration by parts. So I'm once again just going to write the integration by parts formula. Alright, so we're set to go with that. I need to identify a u, and then I need to identify a dv. My u is hopefully something that is going to get simpler, so we're going to let our u be the x squared, which means the dv has to be everything else. So dv will be e to the 2x dx. Alright, so if u is equal to x squared, the derivative of x squared is equal to 2x dx. And then v, if I take the integral of this, we actually took the integral of this in the last video, but I guess I'll do it once again just in case you missed that. We want this to say the integral of e to the u, so we'll let our u be 2x. So let's just do this here real quick. Let u be 2x, du would be 2. I'm missing the 2, so I'll put a 1/2 on the outside, so this really becomes 1/2 the integral of e to the u, which is 1/2 e to the u, which is 1/2 e to the 2x. So, long story short, v is equal to 1/2 e to the 2x. Alright, we are now ready to use our formula. We have u times v, so we're going to have 1/2 x squared e to the 2x. I like just tucking the x squared in between those two. And then minus the integral of v times du. So 1/2 e to the 2x times 2x dx. Alright, let's clean that part of the formula up a second. Let me just rewrite this quickly. Alrighty, 1/2 times 2 will just be 1. And then I like to write my x out front just because I do. Alright, and then there we go. Alright, if you look at this, we are not done yet because I still would use the product rule to find the derivative of this specific function. So once again, we get to use integration by parts again. So we once again have to identify a u and identify a dv. So this part, because it's going to get simpler when I take the derivative, will be my u, and everything else that's left will be my dv. So u will equal x, and so the derivative of x is just 1 dx, and then dv will be e to the 2x dx, and v will be the integral of that, and we just found the integral up there was 1/2 e to the 2x. Alright, so now we are ready to go. So I've got 1/2 x squared e to the 2x minus uv, which will be 1/2 x e to the 2x minus the integral of v du, which will be 1/2 e to the 2x dx. Alright, so I'm going to do one thing, this minus sign here, I'm going to distribute to both parts. So I'm now going to have 1/2 x squared e to the 2x minus 1/2 x e to the 2x minus, well actually that will become plus 1/2 e to the 2x dx. And on this one, we knew that the integral of e to the 2x, we found it 2 times now, is equal to 1/2 e to the 2x. So with this extra 1/2 in there, it's going to equal 1/4 e to the 2x. So my final answer will be 1/2 x squared e to the x minus 1/2 x e to the 2x. Whoops, this was supposed to be 2x. Sorry about that. And then plus 1/4 e to the 2x plus c. And if I recall correctly, I might, in my answers, I'm not sure, I might have noticed that they all had an e to the 2x, so I might have factored that out, so I'm just going to do that just in case. So minus 1/2 x plus 1/4 and still plus c. So that is how we do it 2 times. Now, just a little warning here, if I would have started with x cubed, I would have probably had to do integration by parts one more time because I can eventually get to an answer. It just might take me a little bit. Alright, let's try one more. We're going to evaluate the integral of e to the x cosine of 2x, and hang on for this one, it's quite a ride. Alrighty. To take the derivative of this, we would have to use the product rule. So I know that integration by parts is going to work splendidly. So we'll have the integral of u dv is equal to uv minus the integral of v du. Alrighty, what to let be your u and what to let be your dv. Neither of them are going to get simpler because e to the x will just keep going to e to the x, and cosine is going to keep going back between cosine and sine. I personally like to take derivatives involving the two more than I like taking integrals involving the two. So I'm going to let this part be my u, and I'm going to let the rest of it be my dv. So u will equal e to the x, dv will equal cosine 2x dx. Whoops, that is exactly opposite of what I just said. So we're going to let u equal cosine x, dv will equal e to the x dx. All right, so if u is equal to cosine x, the derivative would be negative sine x, and 2x. The derivative would be negative 2 sine 2x dx. Sorry about that, going a little crazy here. Alrighty, and then v equals the integral of e to the x will simply just be e to the x. All right, set up integration by parts. U times v. So u times v will be e to the x cosine 2x minus the integral of v du. So that will be minus negative 2 e to the x sine of 2x dx. And I'm going to actually make that a plus plus. So now we have e to the x cosine 2x plus the integral of 2 e to the x sine of 2x dx. All right, so first part's done. If I look at the second part again, because I'd have to take the derivative to use a product rule to get the derivative, I'm once again going to use integration by parts. So again, I'm going to pick my same u that I did up here. So this part will be my u, and this part will be my dv. So I am going to get u equals sine 2x, and dv is equal to 2 e to the x dx. I could actually put the 2 over with the u, it doesn't really matter, it's just going to kind of tag along anyway. Alright, the derivative of sine 2x is 2 cosine 2x. The integral of 2 e to the x is just 2 e to the x. Alright, so we're ready to set this up now. So I have e to the x cosine 2x plus uv, so u times v will be 2 e to the x sine 2x minus the integral of v du. And when I multiply these two together, I'll have 2 times 2, which is going to give me 4 e to the x cosine 2x dx. All right, notice I'm set up for another integration by parts problem, and this thing is going to keep going and going and going and going. So we're going to use a little trick right here. What we were trying to evaluate when we do that, we were actually trying to find the answer to the starting problem. So I'm going to actually write what the starting problem was. It was e to the x cosine 2x dx. All right, then I just want you to look at something right here. Notice that these two integrals are actually the same integrals. This just has a 4 that we could actually write out front. So I would actually like to get these, since they are like terms, together. So I'm actually going to add this to the other side. Let's just see what happens. So if I add it over to this side, I'm going to come up here now. I actually now have 5 of those. So I have 5 e to the x cosine 2x dx, and that is equal to e to the x cosine 2x plus 2 e to the x sine 2x. All right, we are almost done. If I look at my beginning problem, it asked me to evaluate the integral of e to the x cosine 2x. Notice I have 5 e to the x cosine 2x. So all I need to do to finish this problem is just to divide both sides by 5, and then I will have found this answer. So my final answer is going to be e to the x cosine 2x plus 2 e to the x sine 2x, all divided by 5, and then plus c. So that would be my final integral. So that would be one where it just goes in circles because nothing ever gets simpler. So hopefully now you can use repeated use of integration by parts to find some integrals.